these two only. Okay. Now let's just perform simple these two tasks first. So what I am going to do, UCL dataset. Okay. This is a repository for dataset for various tasks. Okay, you can see right now, like here, for classification, for regression, for clustering. Okay. So one we need for the classification and other one we need for the regression. Okay. So the first thing that we actually can take here, default task is regression. And yeah, let's actually go with this one, air quality, multivariate time series. No, what we can actually get with, like, you can actually choose your own data set. I am taking somewhat more basic data set right now, and like, okay. So block feedback, multivariate regression. Okay, let's see what we have here. Okay, multivariate number of instances 60,021, attribute characters integer and real. Okay, and this is what we have. Okay, all right. So let me just say the data first. Okay, where is the data here? Data set description. All right, it's weird. Why am I not getting the data here? Okay, there it is. Block feed. Okay, and I have this data set here, ML. And instead of this housing model, we will going to look into the housing model though. But let's just actually stick to the this block feed data, and then just come on here, block feed. Afterwards, photos, ML, and this is what we have, block feed and extract here, right? Okay, this is somewhat a weird data set. Now, what we can actually look here for is just a sec, guys. Like, I'm just looking for a simple data, so you don't really have to, like, let me just actually look for this air quality. Okay, extract here. I believe this should be, yeah, this is actually good to go. And I'm just going to copy paste it here, and housing model, that's where our machine, you know, our data set is there. Like, okay, our notebook is there, right? So let's again go in here, and let's just simply read that CSV file. It's quite easy, right? So here, this is where I believe, yeah, air quality.csv and df.head. Okay, this is somewhat a weird data set. Okay, and let's actually, what we can do, let's actually see the columns of it. Like, this is how you actually get the data. Okay, so don't get worried about it. So air quality, and now what columns do we have here? First one is the date. So we have around like 14 columns here. Okay, so what you can do here is instead, like, going with the attribute information, what you can do, if you actually have seen my one of the web scraping, sessions, you can literally scrap these features with where it is saying attribute information. But what I am going to do, just simply copy pasting it. Okay, and afterwards just simply copy pasting it here. Okay, and what columns do I have now? These are the columns, sorry, like date, time. So you can just type in date here. It's somewhat manual task. I'm just like, you know showing you second, date, time, pt0 true, like it is again. Okay, Let's actually look for these three only. But again, we will be having a problem like we don't have that much time on us. Okay, sorry for actually jumping from here and there. You know what? Like, let's just for once, or let's just stick with the classification one because this regression is making me nuts. Okay, and Abalone dataset. This is what we can look into. Okay, and yeah, this is what Abalone.data. All right, and this should be Abalone.data. Okay, okay, now it is much better. Let's just actually remove this jargon, right? All right, but we don't have any columns yet, so I can actually tell from the first column itself, it is a sex column, right? So what I can do here is just pass on the simple sex. Second one is what it could be. Let's just see in the data. So data set information, attribute information, length, right? It is the next one is for the length. So I don't want to come here and there over and over. So what I'm going to do, just copy, paste, just going to copy this up and we're going to paste it up here. Okay, so the first one is the sex, next one is the length. Okay, next is diameter, height, I will say whole height, chuck weight, twist weight, shell weight, and ring weight. Okay, there are there are no rings though. Okay, rings. Okay, basic rings. Okay, so what we need to do if we actually see the problem statement here, we need to tell how old is an abalone is. I don't know what the abalone is. Abalone, what it is. Let's just see. Okay, this is somewhat a shell type thing that we actually see around the sea. Right, this is your abalone. Okay, and we need to figure out the age of these abalones. If some abalones are like there could be a value for that we will be seeing. Okay, so these are the columns that we need to have in our data set. Okay, what I'm going to do, going to remove this up, and df dot columns is equals to columns, right? And now all I just need to do is just df dot head, and now I have the df dot head ready, right? Okay, so first thing that we usually do, we usually search for the look into the data, like or simple EDA, right? So the first thing that we need to do, okay, I believe I have LENGTH. I just mistyped it. Length. Okay. Height, weight. Okay. Now we are good to go. All right. So first thing that we need to do, usually we do what the EDA simple. Okay. So df dot sex dot value counts. So this many, but it's still like we can tell like first one is the mother and female and infant, and it's quite weird to know like we do if an abalone gets like once an abalone takes birth, like there is no definite gender to it, like we cannot tell if it is a male or a female. It is somewhat labeled as I here. That's what I can actually figure out from this. Okay, and afterwards what we can do here is this. Okay, let's just actually see this in more better way. Value counts dot plot dot bar. Okay, right. So yeah, like we have around like the same number of each abalone type. Okay, But what about like we only had the only one sex for the male, female, and I don't know what I is being called here. Let's just see. Mm, male, female. Okay, this is actually an infant, so we don't know. So it's quite an interesting fact when abalone takes birth. So it's an infant, not either a male or a female, right? So what should be the next step for us? Should be like, let's see what features of these actually, put somewhat correlation to this. That's what I usually do. All right. So first thing that I would love to do is just to ignore this part just for now, or let's just consider this as well. Okay. So what I usually checking for correlation, checking correlation with respect to rings. Why? Because rings is something that actually tells us which, how old is an abalone. All right. I actually couldn't actually read everything out, but this is what we had like. Okay, and maximum value I believe I read around like 25. Okay, so let's just check this. So CORR, DF dot CORR, right? And CORR of what? Rings, a ring, right? So dot sort values, sending is equals to false. All right. So the more the weight is, I believe you can see the values here. So we can tell the more the weight is, okay, the higher the chances of getting the rings on it. Like if it has a, let's say higher weight, the chances are like we will be having higher number of rings as well. Same goes for the diameter, and it is quite axiomatic. If you see, like if it has a large diameter, the weight automatically will going to get increased, right? Same can be tell about like the height and the length as well. Okay, so I believe each feature is actually playing a huge role, and rings like making a ring. Like I don't see any feature futile or redundant here. So we have to take every feature into consideration right now. All right, but let's just check how many values do we have here missing. Okay, how can we do that? Like quite easy. We saw that earlier already. Is na dot sum. Okay, okay. We don't have any, but this is not the usual case. Believe me. All right. And when we are actually dealing with the real world problems, we will be having a lot of. You already saw it, right? When we were dealing with the housing data. Okay. So since we don't have any numerical values, or any categorical values missing, next what we can do, like let's just check the distribution for each of the correlation, sorry, each of the numerical feature. So we can tell like how exactly it was, has a distribution over a single plane or a single feature. So let's actually check for the univariate analysis, right? So how many of you actually know about the univariate analysis or bivariate analysis? How many of you know about it? Please let me know in the chat. Is there anyone else like who does know about it? Okay. So people who actually took my initial, okay, there are people who doesn't know about it. All right. So what exactly it is? Let me just make you somewhat familiar with this first. Okay. All right. So sorry, univariate analysis. All right, what it is? Simple analysis of a single feature. Say we have a feature of height. All right. So what we can do, we can plot out a distribution plot. Let's say it could be a bell curve. Okay. And this single height distribution can tell us a lot about like how the data is being distributed, right? What sort of data do we have, and what sort of percentage do we have of the simple data? Like it is around like mu minus 3 sigma, if you remember. Oh, sorry, if you know it. Okay. And this is mu plus 3 sigma. Like it actually follows what we say, a 90 68 95 99.1 rule. Okay, this is your bell curve. Like we won't be going into the sorry, with the probability and stats and data analysis thing right now, because this session is intended for. But if you really want to know about it, I believe I have taken sessions for that. On You can actually find those videos on the Let's Upgrade itself. Okay, so please do check those out if you really know about what are the analysis and distribution and everything is. Okay, so for the first thing that I actually want to do is just going to make a simple distribution for what? My height, not for my height, of yours, like for the length of this this abalone data. Okay, so let's do that. SNS dot dist plot. We have a dist plot method in the SNS. Okay, what it takes just simple a feature. Let's just say length. Sorry, make it out. Sorry. Okay, so you can literally tell like for the length or for what is the most common. Why it is this plot is replicated will be removed. Okay, just ignore this warning. Okay, just for now, like it is asking us for plotting this out instead. It's actually, if you do that, it won't be having any issues. Okay, but let's just actually stick with the distance right now. So yeah. Okay, so what exactly this plot actually tells us, from point 0.6 to around point what we can say, like around point 0.7, I believe. Okay, we have the most number of abelons here. The least number of abelons that we have are the smaller ones, which are zero point 0.2 centimeter in the length, and we also have around like lesser number of abelons which are around like zero point 0.7 to zero point 0.8. Okay, I hope this is actually clear. And even if we actually check this out, define print max length of abelon, what we can do, max of df, sorry, max of df of length dot values. So yeah, it's quite obvious. Like the max length of abelon that we are getting right now is 0.815, and same goes for what? Minimum. Okay. So the min, we how we exactly we can get min length of abelon is, just type in min here, 0.075, like somewhere around here. All right. Okay. And this is actually univariate analysis. The same thing that I am gonna do for what? Uh, this was for the height. Just actually, why don't we actually type in here abelon height? Okay. And let's just actually do it for abelon weight, maximum and minimum weight. So what I'm going to do again, SNS dot hist plot df of weight Okay, diameter. Let's just actually check the diameter though. Okay, so this is the diameter's value. You can check this out. Like I believe this is actually much more readable if you see. Like we have the bins value here. So how many of you actually know about the histograms though? If you don't understand about the histograms, that it might be actually a trickier one. Do you guys know about the histograms? I know, I know. Okay. All right. Just to actually, okay, so most of the people actually does know about the histograms. Yeah, histograms in MATLAB will not going to differ here from the histograms. Okay, so just all right. So basically, it tells you about the cumulative frequency for an interval. That's what it actually says or do. So if we actually tell, like if we actually say 0.45 to point 4 to 0.45 point 0.5, we can tell like there could be around like this many of uh, abelons which actually belongs to this diameter. Okay, and same can be told for what we have seen the length, we have seen the diameter, we haven't seen the height though. Okay, so let's do that for the height as well. SNS dot is plot. And just pardon my, like, please excuse my voice today. Like my I am having a mild fever and mild viral, so that is why I am stuttering and stumbling upon some words. All right, so please pardon me for that and excuse me for that. Okay, so let's actually see the height as well. Okay, so yeah, for the height, what we can do, simple this. Okay, this is actually weird. So the maximum height of an abalone that we have here is like zero point 0.2, and we can actually do the same for the diameter as well, right? So let's actually do the diameter, max diameter. So what we can do, max of df of diameter dot values. Okay, and here is minimum diameter, and we just pass on the min. So maximum diameter is 0.65 centimeter and minimum diameter is 0.055, right? And we can also tell this from this graph itself. Okay, like estimate only, not we can thoroughly tell about it. Okay, and same can be done for this height as well. All right, so if we actually go with this and this, right, all we have to just type in the height and maximum height. Okay, so we have the data that has the minimum height as 0 as well, and I would love to check this out, like how many. Okay, so what I can do, minimum height, and what we can do, like df of height is equals to 0 0.0 of what, df. Okay, like we do have two abelons here who doesn't have any heights. Like is it even possible? I don't think so. Okay, and I think this is somewhat missing, right? I believe like this is just actually found, and I believe this should be imputed as well. Okay, because uh, height cannot be zero. Like there has to be some value for it. Okay, so yeah, we will going to look into this for sure. Okay, but what I actually saw here, like it was quite startling to me. That is why I actually checked it out, like what values do we have here. So we can tell like there are two values, which there are two abelons which doesn't have any heights. All right, okay, and you can do the same for the viscera weight and shell weight as well. I don't think so like I should be doing for every weight here or every feature here, sorry. Okay, and but I would love to actually go with the rings though. Okay, so let's actually count plot df of rings. All right, okay, my bad. data is df, and this is actually your x. Yeah, now we are good to go. Okay, and this is actually your ring numbers. Okay, like you people can see, like most of the rings that we have is around like 9 to 10, like 8 to what we can tell, like 11 the maximum. Okay, so like we have around like average of those 500, and maximum we have around like 10 for what we can say, like for the 9 we have around like this many. Okay, I don't know what the number is here. All right, so yeah, we do have the rings that has like maximum rings that we have is around like 29, and we can check that value as well. How exactly? I'm just going to type in here like what rings. Okay, so maximum rings that we have here is 29, and minimum ring is 1. Okay, here you can see it. Okay, but what I am actually having a notation, like what exactly I am having mm, an intuition about, like what if these rings are like, is it actually possible? Let's say, let's consider a scenario. Is it even possible when a ring has been formed, sorry, when a ring has been formed, is it possible like after forming up for the first ring, like there will be only the case the second ring will going to appear? Don't you think like there could be a chance where second ring will might actually start to appear? Right. So what I can actually tell from this data, like this is actually one ring, and this could be like one and a half ring. So is it possible or possible not? Like I've never dealt with this Abalone data. Okay, I am doing it in front of you live. Right. Whatever we are doing, like it is something new to me. I actually I could have just prepared the entire notebook, but I don't think that will be helpful. Like you already saw me how many times I stumbled. Like it is quite natural. Okay, so do you guys think is it even possible, like just for the appearance of the second ring, it will just going to be a whole ring instead of a partial one? Okay, is it possible? Please let me know in the chat. Okay. So what I actually of thinking of doing it, like why don't we actually convert this entire ring into what we say, like into the floating values, I believe. Okay, and that way I could have like 1.3 rings. Okay, like I believe this actually makes sense. Okay, all right. So let's actually do that. So df of rings, df of rings dot d type, or apply np dot d type. And wait a second. Okay, I actually didn't want float. Okay, now we can see we do have the values in the floats though. All right, and they have actually deprecated it again. Like I believe they are asking for 64 here. So let's not have this warning. Like warnings actually sometimes gives me unnecessary anxiety. Okay, right. The half ring will be a unwanted data. Wanted how exactly, Kabilan? I would love to know. Like how half ring would be unwanted. Can anyone tell me? Like is it possible or possible not like to have have a ring around like on Abalone? one ring and somewhat a partial ring. Just answer me this. Is it possible or possible not? Like, is it yes or no? Just tell me this. Like, if I actually see it on an abalone image. Okay, abalone. Okay, it's right. So, do you really think like abalone rings? Okay, this is somewhat weird. Age. Yeah, this is what we are actually looking for. But can you really tell here like how many rings are being formed on this abalone? Do you really can tell like there are 25 or 26? Like I don't think so. I would love to know your opinion though. Like what do you think, guys? The half ring will be unwanted. Yes. Please explain sort by in pandas. Possible. It's quite possible, but it doesn't make sense if we include it here. It doesn't make sense. Why though? Like I would love to know about like why. So you want me to actually go with the only integer values instead of floating one. That's what you are saying, right? Why don't we actually see the entire flow with the two of the approaches? Okay. First, actually tackle this. Like let's just assume let's just assume for this one, for this class, we will be having 29 classes. Okay, just actually think as a data scientist, or just with the simple logic. Like, is it really feasible to even to predict 29 classes? Like, I would actually go with the like, okay, it could have like 2.5 rings or two rings, and third ring is being formed right now. Okay, this is what I am actually approaching it. The way I am actually approaching it right now. Okay, and someone is actually asking me over and over, please dot values. Okay, Sai Harsha, what dot values you are asking for? Dot values is basically your extracting the numpy array for a single ring. Okay, when I say df rings, this is what I get. I want these values, the these values. So what I do, I simply convert the those values into the numpy array. That's what it means. Okay, all right. So I'm just saying about the half rings. Lol. Yeah. Okay. So please explain sort by also. Yeah, I will. Okay, don't worry. Sort by basic. It tells itself like sort by sorting the values. That's what it is doing. Okay. So yeah, like where exactly you saw the sort. Yeah, here. We are sorting up the values. That's what it is doing. And ascending by default it actually uses ascending, and we want the values in the descending order. Okay. So that's what we are getting here. All right. So I am actually gonna go with the floating values here. Okay. There are the chances. Okay. So this actually task has been converted from the regression to the classification one. Okay. All right. So yeah. All right. So let's actually see. We were actually having the some of the data here and there. Like if we actually see here the maximum value, let's actually calculate the maximum value other than sex. Okay. For columns and df dot df dot drop x dot columns. Okay. Now what I want is df of print print multiplied by, let's say, 30. Okay. Print df of mm, maximum value. I want maximum value. I want to check what are the maximum value I am getting. Max or column is this much. Max of df of column dot value. Sorry. at the inside. Same goes for the what minimum min rent hash multiplied by 30. And let's actually remove this as well, the first one, because we don't need it. Min, and I want here min. What happened? Okay, I haven't defined a this equals to 1. All right. Max for length is 0.85. Min for length is this much. Okay. So yeah, like you can see here, for the diameter we are actually getting like the deviation is quite a little bit, bigger, like even for the viscera weight, right? So we might also need to normalize these values as well. Okay, so it's quite easy to normalize the values as well. Okay, so let's do that, because what happens for the machine learning's perspective, what we are actually here now right now, like data pre-processing, that's what we are at. For the machine learning's perspective, what happens, like when we have the higher weights, when we have the higher weights, our model actually, what it does, like it tends to overgeneralize those higher weights, basically overfitting. And by normalizing any value, it improves the data quality as well. Okay, so it's a general practice what we do as a machine learning task, in a machine learning task. Okay, and but for the rings we won't be doing it, because this is something that we want to actually predict for those two. Okay, other than that, I'm just gonna impute those values, and afterwards, yeah, let's just see. Okay, so data pre-processing for what? Numerical value. So I need numerical data first, numerical column, so you can say. How can I do that? Call for df dot columns if, wait a minute, if df dot column dot d type and what, float or 64, sorry, int. All right, I believe it will gonna do with the float, right? Okay, but we also need to check. We're just gonna remove like if d type, like it is getting actually much more than that. Why we actually, let's actually stick with this first. These are the numerical columns. Okay, when I actually print them out, let's just see. Okay, so rings, we don't want rings though, right? So what we can do here, numericals dot column remove rings, numerical columns, right? So these are the numerical columns that we want, and what we need, numerical df now. So what we can do for that case, df of numerical columns and numerical df dot head. Okay, so now we have the numerical data frame. Okay, only. And now what I want here, I want to scale this, like I want to normalize this data first. All right, how can I do that? It's quite easy. Just okay, for first, like I can tell you sklearn normalize. Just go in here. Okay, and afterwards you can see, like it just takes the x value. Okay, and other than that, like we are good to go. Let's actually see that in action. So what we will gonna do here, from sklearn dot from sklearn dot pre-processing. Okay, import normalize, right? And afterwards what we need to do, simply call this up. Let's actually check this out. Okay, so what it takes, like it takes the value only. Okay, so let's actually pass on the numerical df here. I don't know why it is not coming. Okay, so now you guys can see, like we do have normalized values. Okay, and like it is not the same as we had earlier. Like I can tell you here how pd dot data frame. Okay, so these are not the same values. If you actually see, like just ignore the columns for now. Okay, all right. So what I can do here, I can just simply call it like xnum, and xnum normalize numerical df, right, and simply print out the xnum normalized. Okay, now what we just did, we just normalize the values. All right, now the second thing what we need to do is the tackling the categorical values. Okay, so let's just see what categorical value do we have. So xcat, if I actually have to name it, or cat df, just name it cat df, and df of what we can say, mm, sex. Okay, this is what we have, right? And when I actually check this out, cat df, this is what we have. Okay, mfi. But in machine learning, we cannot feed the object values to a machine learning algorithm. Okay, we just can't. Okay, so what we need to do, we need to pass on, we need to input the numerical values. For that, what we can do, what usually machine learning process actually tells us to do, it's called one hot encoding. So what exactly it is, let's assume that you have a, b, and c, like in this manner, in that manner. Okay, so what exactly happens, like we can just make a we can just make a matrix where if a is present, I am going to label it as 1 and other will be going to 0. Same goes for if b is available, it will be 1, other will be 0. Same goes for c, if it is available, other will be 0, others will be 0, right? That is how we actually can convert our categorical values into a numerical one. This process is nothing but your one hot encoding. Like it is quite, you must be understanding the entire terminology with the naming convention itself, what it does. Okay, so whenever we actually see the values here, like let me just bring up the sklearn dot preprocessing import one hot encoder. So I'm going to name it one hot encoder, right? So what we can do here is simple this one hot dot fit transform. Okay, and next thing that we need to do is cat df. Wait a minute. Mm-mm-mm. What happened? Just a sec, guys. One hot encoding sklearn. Okay, so this is what we have, right? Handle unknown ignore. Okay, dot fix. Okay, so first initially it is actually transforming it of. Okay, but it should work though. Okay, it's weird. Okay, Why it is not giving us? Hmm. I don't know why it is not working, but I have a different option for that as well. Okay, this could be a first option. Don't worry, I will going to solve it before actually leaving this. But I just want to. Second option here could be is get dummies. Pd dot get dummies. Okay, and it takes df cat. Sorry, cat df. Okay, so now we have that data frame that I was actually talking about. If we actually see that for the m, what we are getting right now is the one. For the f, we are getting one. Like you get the gist here. Okay, and what you can do here, just pass on the values, and now you have what we can say x cat values, right? Okay. All we need to do now is just concatenate these normalized features along with these category one hot encoded features. How we can do that? It's quite easy. Okay, so let's just see np dot, sorry, c, and this actually takes, I believe, this the way it is like xnum and xcat. Okay, yes. Okay, so what I can do here, I can just name it as final data. All right, and print on the final data here. Okay, now we have somewhat a data that could be, feed it to our machine learning models. All right, yeah, I will be answering your questions, don't worry guys. Okay, so now comes the predictive modeling, and before that I can take questions. We have the data actually ready to feed into the models. Okay, and actually we can also check out the shape as well. This is what the shape is. Okay, initially I believe we had the shape of around like 11, right? Wait a minute. Like if we actually remove this, yeah, 9 and 3 12. Yeah, it has to be around this one. Okay, so I'm just hoping saying about the how. Okay, sir, explain stored by. Yes, I did. Sir, no need of axis one for dropping. Yeah, like we need to tell for which axis. For axis is equals to 1, it tells like to drop from the columns, and axis is equals to 0, it tells to drop from the rows. Okay, all right. So what is the next question? How to use normalization, when to use standardization, and how to choose. Okay, Sai Harsha. Standardization is more of your, removing what we do with the standardization. Let me explain. Okay, normalization is nothing but you're scaling the values in a same scale, and believe it or not, standardization, what it does, like with the same thing. Okay, all right, so what we can do here is this. So normalization is nothing but putting every value on the same scale. I have already explained it. But scaling the values, right? Standard scalar. If you actually go with the mathematical approach, what actually happens, like xi minus mu I upon mu I, like xi. This is what we have for the standard mm, mu one. Like let me actually see that standard scalar. I believe they must be having a value. Okay. What we do, yeah, basically we actually scale the values from the mean and variance. That's what we do. I just don't remember the exact formula here, but I can tell like it actually takes the value from the mean and variance. Okay, but whereas in the normalization we tend to squeeze down the all the values between 0 to 1. Okay, so yeah, when to use it? Standard scalar. It is good when you have like a drastic problem of heavy weights. That's when you can actually use standard scalar, because because your weights, let's just actually, let me actually come in here. All right, okay, now it is working, because your weights sometimes can be, highly right skewed and left skewed. So that's where you might actually want to check out the standard scalar for this part. So put into the same scale, like somewhat like this. Okay, so it's in series. What if there is, what if there is a case when two values need to be converted? I don't understand what is there is a case to two values. I don't understand, Kapilan. Please explain your question here. Sir, how we import customer data to our software? I don't understand your question either. How to choose encoding technique? We have many techniques, right? Please explain briefly. Okay. Like it is quite like what sort of encoding technique you are looking for. Okay. We have encoding techniques in NLP as well. Okay. So encoding basically nothing but converting your textual data or any objective data into a numerical one. That is what your encoding is for a superficial level. But how it is done, like it is a huge topic in itself. Like we have lot of encoders, so it's quite a vague one to answer. Like this one you should be using and this one you should be not. Okay, machine learning encoders sometimes is like we call it black boxes as well. We don't know what actually going to work. All right, like label encoding, binary encoding, one hot encoding. Okay, I believe label encoding has more to do with the labels itself. You have already, but for that I usually use label binarizer if I have binary classes. Like okay, and if I have to convert those into the binary labels, of course, like 0 1 1 1 1 1 0, like okay. Okay, and one hot I have already told you for the features, for the independent features, of course. Okay, sir, when will we find the assignment question? When you converted the sex values into the matrix, what if there is more than two values? Like the person has two things out of at once. Okay. The sex values into matrix. What if there is? I don't understand your question, Kabilan. Like, can you give me an example for that? I don't really understand. Like, a person has two things out of three at once, while other person has one thing at once. Like, I really don't understand what you are trying to say here. Okay. All right. Okay, so this is our last predictive modeling, like not the last, but of course. Okay, and this is your X as well. So final data that we will going to train our model on. And if I have to say like the labels, what will be our labels? DF of rings here dot values, right? And if we actually check this out, the labels dot shape, we have the same shape here. Okay, so now we have the features, now we have the labels. If I again reiterate what I said in my last session, we have a matrix here. This is a total matrix, this is the matrix for the features. This is the single value matrix, single vector matrix. Okay, this manner and this manner. Now what we will gonna do, now we will just gonna train our model, train our model on this data set. All right, I hope this is actually clear. Okay, so let's do that. So I will going to bring up some of the more selection, import, train, test split. Okay, and the next will be from sklearn. Since I have actually converted this task into a regression model, I'm just going to simply use what we say linear regression, and also we can use what we say like decision tree as well. And just I'm telling you guys, like, this class is not uh, for like understanding the each and every algorithm. We are just experimenting on bunch of the algorithm that are available with the scikit-learn and ensemble random forest regressor. Okay. All right. So now what we can do here is xtrain, xtest, ytrain, ytest, train test split, final data and labels, test size point 2, and random state. Like we want uniform samples, so I will just going to define any random state. Like it doesn't matter what number you actually pass on here. So yeah. Now if we actually see print training shape, testing shape. So training shape that we have here is 3340, and testing shape that we have here is 836. Okay. So this is the data that we will gonna test our model on, even with the accuracy and everything stuff. Okay. And let's actually train our model first. Okay. So let's actually simply bring up the linear regression first, and lr.fit train. Wait a minute. And y train. lr.score. It takes x test and y test. If we actually check the let me actually name it test score. Okay. And print testing score is test score 59.72 percentage. Whoa, this is way worse. Like, not at all good. Right. And let's actually test it for training. Okay. I believe like not so much an overfitting or underfitting either. Okay. Why don't we actually check out like how exactly a model is calculating the score for each other. Okay. But for each epoch, I don't think so that will be the case. Let's actually don't stick with that first. And since we actually tried a model with the linear regression, why don't we actually try a model with the decision tree as well? Okay. Right. So dt decision tree regressor, again dt dot fit x train y train dt dot score x train and y train. Let's just see if it is actually going to do. Oh, okay. It is actually, I believe it is actually overfitting now. Okay, and x test and y test. Okay, it's highly overfitting right now. Okay, like for the training data set, we had around like 100%. Like when you actually get 100% testing accuracy, okay, or sorry, training accuracy, or even though if you get the more accuracy, like there is a concept called underfitting and overfitting. Okay, so what happens like if you have around like the same number, like let's just say if the testing accuracy is somewhat closer to the training accuracy, this is the right model. If it is way less, if training accuracy is way bigger than the testing one, it is an overfitting. Okay, and if the case is reverse, it's an underfitting. All right. So our decision tree is severely overfitting our model. Okay. So which we don't want. Okay. So what we can do here, why don't we actually use hyperparameter tuning? If you do guys remember what it was, right? Uh, I am new to machine learning, so I don't know what. Please explain random state. I just did Sai Harsha. Mm, all right. Hey Abhiram, I'm doing fine. Sir, if it is necessary to complete assignment all day because I'm like I there was no assignment for day one, Vatis. So you are good to go, I believe. Okay. All right. So yeah. So let's actually try this with the random forest as well. Okay, then we will going to hyperparameter. We are just going to tune it a bit. Then we will going to check it out how well our model is doing. Then we are good to go. So last but not the least, random forest. I believe it might actually do well. Random forest. Let's actually take the number of estimators. Here we have like no. Let's not actually bore you with that. X train, Y train. All right. Now random dot score X test Y test. Whoa. Now we have the maximum like okay, and X train Y train. Whoa. So I believe sorry. I believe like random forest is somewhat excelling like for the linear regression model. Like for it was like 59 and 72 and we have 59. No. Actually simple linear regression model in this case is doing really well. So what we can do in this case, why not we actually perform hyperparameter tuning. If you guys remember, like with the 3 line example I showed the other day, right? The best parameter was the your slope and the intercept. So why don't we actually perform here hyperparameter tuning and see if we can actually tweak some of the parameters and get better accuracy. Okay, so how we can do that? Just simply grid search CV, right? Model selection. Okay, this is what we need to do. Just simply grid search CV. Okay, and the parameters that we want. Okay, let me just copy this here. Okay, but I want the parameters as well. Okay, get parameters. Sorry, because I don't know about the parameters though. Okay, so n jobs first, normalize fast. Like it doesn't have that much of parameters either. Okay, what about the random forest dot get parameters? Yeah, it does have a lot of parameters to tweak. Okay, we will gonna get into both of those. Okay, but let me actually let's just see how well it can actually do with the n jobs and everything. Okay, we will just going to put normalize equals to false and true and positive equals to false and true. Okay, and fit intercept and false and true. Let's just see how exactly it will gonna go. So grid model LR model, what we can do here, grid search CV, linear regression. Okay, this is what it takes, right? SVM, simple linear regression. Okay, And now we need to define the parameters, params, right? What we can do here, we had these parameters. So for the first iteration, what it is doing, like for the kernel, okay, let me just copy x and true. I don't think like this is actually going to matter. Like I believe fit intercept is something that fit intercept and normalize, like this is all we need. Okay, this is all we really need right now. All right, so okay, normalize. Okay, I want this to be true. Okay, and the second is fit intercept. I want this to be true. Like by default it is true, I want this to be false. Okay, let's just actually check this out. And I have lr and parameters. Okay, and let's train a model. X train, y train. Boom, we do have dot best. We have simply best things here. Okay, so best score is this, and grd lr model dot best parameters I would like to check. Like we didn't pass on the false and true. Okay, so this was actually for the only one iteration, I believe. Okay, like there could be a case for false as well and true as well. False normalize should be true. Okay, and the fit intercept should be false, and I believe that is what they are doing it by default. Okay, so okay, no, exactly, normalize equals to here is true, and this is what we are getting. Okay, and if you want to extract the best model, what you can do, grid lr model dot best estimator. This is your best estimator. When you actually check this out, this is your, these are your parameters that you can see here. Fit intercept false and normalize equals to true, and you can now check the score as well for the test and white test. Okay, 59 and 52, like this is the same that we actually got earlier. All right, so why not we actually mm, do it for like, okay, random forest. All right, but random forest is something like usually I do it on my own because it takes a lot of time. Let's just check this out. Okay, random forest tuning. All right, so let's actually do that. Grids or cv. All right, so first thing that we need here is random model. Okay, and parameters, of course. And estimators. Right, and let's just actually check for like 5, 10, not 5, 10, but 20, 40, 80, 150, 200, 250, and 300. All right, and also check for what, uh, maximum samples, like there is this leaf or something, max depth as well. Why don't we also check for the max depth? 5, 10, 20, 25, and 30. Right, and go with the out of bag score. I don't think so. Like we have actually, this is actually something like bootstrapping and aggregation thing. Out of bag score, oob score, that we also say. mm, yeah, we can actually check the bootstrap also. False and true both. Right, and last, minimum leaf split. Okay, like with what value we will going to split a branch with. Okay, let's just say 2, 4, 6 and 8. Okay, these are the parameters that I just defined, are n params rnd dot fit x train y train. Shouldn't take that much time, but okay, let's try this out. Okay, so how many features do we have here? 7, 5, 12 to 14, 18, and we didn't define the cross like for how many iteration we want to do. Like we can define the cv as well here, I believe. Okay, but we did not. Okay, all right, it might take some time, guys. Okay, can we use validation set instead of hyper? Yeah, you can use cross validation technique, Sai Harsha. But cross validation technique actually helps you for the overfitting and underfitting, things, like not for the hyperparameter tuning. Like you can do it, but I believe this, there is an approach is like, I'm not sure like how exactly, where exactly this might actually fit in, where exactly that might actually not fit in. Okay, so it is always a do and hit and trial thing. All right, so this is what we did till now. All right, it might take some time, that is why. Okay, so meanwhile what you need to do, let me just tell you about your task. Okay, housing data, housing data, housing price prediction. Okay, this is your housing price prediction. What you need to do, guys, go here for the Kaggle. Okay, housing price, not the solution though, but the prediction. And go here for the Kaggle. We already downloaded the data. All right, and perform whatever we have performed on this Abalone data set. You don't really have to know about the each and every algorithm in detail right now, because we haven't covered, like it is not possible to cover machine learning in 2 days, of course. But we have covered how exactly we can come from scratch, then again give it again, giving the columns each and column name, then processing it, then somewhat visualizing it as well. Now we are training it, and lastly we are hyperparameter, just tuning it a little bit. And it might take some time, and for that, and for I'm going to add on some links as well, how you can actually tackle the missing values, and how you can scale the values as well, and also can normalize. Like I will going to add the instructions in the notebook itself, or in the assignment itself. Okay, and it will be uploaded like in next 3 or 4 hours, because I need some time to actually design. Like I will be needing some time to design the entire assignment. Okay, okay guys, like I don't know like how much time it will going to take. Okay, right, so till then we can actually have some conversation. Are there any questions for me? Any questions? I can take questions now. Can you explain group by in Panzer? Do you know group by in SQL? Right, actually we group by in with respect to a category or with respect to a feature. Okay, so yeah, like grouping by is nothing but, say you have say you have A, B, and C features. Okay, now you want to group by, now you want to see the relevance to this feature only by considering these two. So what you can do, you can actually group by the entire values with only C and can take the relevance to it. Okay, to make you actually more understandable, like to make you, you know, what we can check pandas group by. Like they do have, what say, like some of the, like these here, like okay, so the moment I actually group by it, okay, with the animal, so now I can tell like falcon has 3 7, like okay, so that is how I actually used with the one feature, how you can actually decide the other two features relevance to each other, or sometimes even comes handy for designing the data as well. Guys, it might take a lot of time, like okay, all right, if no, like yes, Athira, I meant by that, like DB SQL group by. Can you explain by the about validation? Can I send assignment in WhatsApp? Now, no, you cannot send your assignment in WhatsApp. There are clear instructions about how you can submit an assignment on Let's Upgrade. Please do follow those. Okay. Uh, so can you explain about validation? Validation, you can actually consider that like while you are training your model. Okay, you might want to actually check out for each epoch how well your training model is doing. So what you usually do, you tend to follow up a folding technique. There are there are two or three folding techniques like k fold, stratified fold. Okay, cross validation technique as well is there. Okay, but let's actually stick with the cross validation for now. Okay, so what you do usually, you take your training data set, you make folds of it. Okay, what you do then, you take this as training and you validate this training model on real time, on fly, on this trained model, not the data but the model. Here, basically validate here. So this holdout fold is not your validation data. Okay, that is what we do with the validation data. It is not from the inference, but it helps you to determine on the while you are training your model if your model is doing good or not. Okay, what is time series data set? Sayersha, you actually bring questions from like 2 or 3 slides, like even from those, like okay. All right, I can tell what is the time series data set. When we have temporal data sets, let's say your stock price prediction, it is your time series data set. Okay, where you have a temporal, graph or the temporal graph in your data set, like what will be the what will be the weather or what will be the temperature for Jaipur yesterday, sorry, tomorrow, and what it was yesterday. All right. So when we have time, that is actually your, all right. Ma 9 learn machine learning book references. I prefer 100-page machine learning book. Okay. Other than that, I also prefer Tabishami, and I don't remember the name though. Elemental statistical learning, that's we say usually. Okay, that you can always prefer to, and still taking a lot of time. That is why you should not do machine learning sessions and while coding live, right? And this is actually quite normal. Okay, when your model is taking that much time even to train, and yeah, I will just going to post the answer into the community itself. Okay. All right. So do we have some evaluation metrics in ML and DL? A lot actually. Sahi Harsha. For it depends upon the every regression and classification time series data. It matters from one to another. Let's say for the regression we have mean squared error and mean absolute error, and for the classification we have precision, recall, ROC, right, F1 score, such. And the DL just don't ask. Right. So are there any questions? Like we are pretty much done for training the data. I'm just going to design the assignment for you guys, how you can actually approach it. Okay. And then you should be submitting those assignment to the Let's Upgrade. All right. Any questions for me, guys? Any questions? Thank you, Sai Harsha, for being here. Thank you, everyone, for being here. Okay, it means a lot. Yes, Abhishek, ask if you have question. All right. If not, then how to solve the assignment? Really, guys? Really, Abhishek? Okay, I will going to actually tell. I will going to actually describe in uh in the notebook assignment itself. Okay, don't worry about it. I will provide the instructions, but not the solution. Okay. Okay, everyone. Thank you so much for joining in. How do you learn all technologies like web scraping, MLP, computer vision? Like it is a tough question to ask honestly. I don't know how do I learn. I just learn. First, you really need to decide if you really want to learn or not. If you really want to learn, you can literally learn. Otherwise, no one can make you learn. So I always have a learning mindset and I learn. That's it. Yes, I will. Like, do check out the community link. Okay. All right. You are my. Thank you so much, Sayesha. Okay. Okay. Thank you so much for joining in, guys. It means a lot. And have a blast. Bye bye. Thanks.